Hello, today we are going to discuss a new topic and let's start with its name. Its name is actually dynamic programming. So, what is so dynamic about it and why is it actually called dynamic programming? Well, the story behind its name is kind of funny, but we'll discuss it some other day. But we will, hopefully. So I want to call this dynamic programming a mysterious savior in disguise. So why do I call that? Because I actually wanted to come up with a cool name, and finally this is what I came up with. Not so cool actually, but there is meaning to it. I am calling this name mysterious because the way dynamic programming works has actually doesn't have much to do with its name, dynamic programming. We will actually realize it when we know the story behind its name. And it's a savior in disguise because there are some problems that can be solved with dynamic programming, but at first sight you may not realize that it can be actually solved that way, or maybe it needs some critical thinking. So that's why I am just calling it a savior in disguise. So the moment anyone actually first hears the name dynamic programming, they may think, actually I first time thought this, that what is this dynamic programming? What does it do? Is it really a powerful technique or maybe a simple one and has a heavy name? And when we will know a little more about dynamic programming and see that how it can solve some problems in a really cool way, we may start to think that dynamic programming may solve all our problems. But is it actually true? Well, that's kind of debatable, because there's someone who said that given enough time, let's say infinity time maybe, any problem can be solved using dynamic programming. Is it actually true? Well, I think that's debatable, but someone said that. So let's dive deep into the world of dynamic programming and see what it's all about. Maybe we'll unravel its mysteries, or maybe we'll not. Let's see. So before diving into the world of so-called dynamic programming, we will actually take a teeny tiny detour, but I promise you that it will pave the way into the world of dynamic programming. So let's start with a series, and I know that maybe almost all of you have already recognized this series. This series is called the super ultra famous Fibonacci series. So why this series is special? What is the pattern behind it? So even if there is someone who hasn't heard of this series before, even he or she can actually recognize that there is a simple pattern in this series. That is, any term of this series is the summation of the previous two terms. As you can see here, that the third term is the summation of the first and the second term, and the fourth term is the summation of the second and the third term, and so on. So the first question one may ask, that what about the first two terms? Because for the first two terms there are not two previous terms, so how do they come into place? So actually they are predetermined. That is, the first term of this series will be 0 and the second term of this series will be 1, and from the third term we can actually build the whole series on that. Actually, some people say that the series actually starts with two ones, the 0 is not included, and some people say it is included, but in official definition of it, the 0 is included, so we will stick to that. Now, what is the pattern of this series actually? So if we denote that, let's change my color here. If we denote the nth term of this series as fn, then we can see that the nth term f of n is actually equal the addition of the previous two terms, that is f of n minus 1 and f of n minus 2. That's pretty self-explanatory, that these two are the summation of the previous two terms, and we can easily check that this is true, because let's say that this is an array and the series starts from n equal to 0, so this would be f of 0, this would be f of 1, and so on, as you can easily check, and so on. So as I said, that the 0th term and the first term are pre-declared, that is the 0th term will be 0 and the first term will be 1, and you can easily see from here that the second term is the summation of the first term and the second term, which is 1, and you can actually easily build the whole array or whole series, whatever you like to call it, from there. So you may actually think about why we are doing this, why we are explaining this Fibonacci series, which is known to many of us. So there is a reason. What is this? What is its relationship with dynamic programming? So let's get started with that. So as you can see that the nth term of this series needs the previous two terms to be measured, right? So let's say you want to measure f10, then you need f9 and f8, but you don't know f9, right? So for f9 you actually want to know f8 and f7, and you don't know f8 either, so you inquire about f7 and f6, and it goes on. And at last, when you reach either f1 or f0, you have an answer because they are predetermined. So f1 is 1 and f0 is 0, right? And then you can slowly build your way up to f10. Let's look at a really small example. Let's say you want to determine what is f4, which is 3, by the way, we know it right now, but let's say you don't know it. So you will inquire that what is f2 and f3, because the summation of them will be the term f4, and you don't know f3 either, so you actually ask what is f2 and f1, because the summation of them will be f3. Now you know f1, but you still don't know f2, so you again ask what is the summation of f0 and f1 to determine f2, and now you know that f0 is 0 and f1 is 1, so f2 will be actually 1, and now that you know f1 is 1 and f2 is 1, f3 will be 2, and at last you know that f2 is 1 and f3 is 2. Now you will know that f4 is 3. That's how it's determined. So we actually want to write a small code for that, because we're doing programming, we ultimately have to turn everything into codes. So let's get into that. So let's say we have a function which actually returns an integer which is the nth term of the Fibonacci series. So how will we write it? So we will have a variable, let's say its name is val, and as this is a function which returns the nth term of the Fibonacci number, where n is the parameter. So to determine the nth term, you actually need n minus 1 and the n minus 2th term. So you call the same function. This is a recursive function, and I am assuming that every one of you know a little about recursive functions. It will call itself, and the parameter will be n minus 1 and n minus 2, and the results it gets, it will add them up and then store the value into the variable val, and then it will return the value. This will be the basic property of the Fibonacci function. So we can easily see that f5, or let's go to a smaller example, f3 will actually want to know f2 and f1, right? And they will go on from there, and f2 will want to know f1 and f0. Now this code is not complete, because if you remember it, every recursive function needs a base case, otherwise it will not ever stop. Because when this function will want to know f1, this will call upon f0 and f minus 1, where this term is obviously invalid because there is nothing called f minus 1. So this code will actually run forever, because when f minus 1 will be inquired, it will actually go for f minus 2 and f minus 3, and so on. It will go on forever. So we actually have to stop at some point to stop this, and that is what we call a base case of a recursive function. That is where this function will stop. So this function, it will actually should stop at 0 and 1, because those are the predetermined terms and there are no terms before them. So when the function inquires that what is f of n when n is equal to 0 and what is f of n when n is equal to 1, it actually should return 0 and 1, and now this function will work. It will never fall into an infinite loop. So now let's build a tree out of it. So we don't know maybe much about tree, or we may know, but that doesn't matter here, you will get it. Let's say I want to find out what is f4 is. Now according to this code on the left side, f4 will ask what is f3, and then it will ask what is f2, and then it will add them up and determine what is f4. But as many of you should know how recursive function works, when fib of n minus 1 will be called, a new instance of this Fibonacci function will be created, and that will be executed first, and then Fibonacci n minus 2 will be called, not before that. First Fibonacci n minus 1 or fib n minus 1 will be executed completely, and then fib n minus 2 will get executed. So when f4 actually calls for f3, f2 will be called only after f3 has finished working. So f3 will call f2 and then f1, but f2 has still not finished. f2 will call f1 and f0, and this function, when it will reach 1, it will not call any further. It will actually return its value, which is 1. So f1 is 1, and then f2 will call f0, which will return 0, and adding them, f2 will be 1, and thus f2 will be completed, and only then f3 will call f1 again, because f2 has been completed, and f1 will return f1 and f3 will be calculated as 2, and then f4 will call f2, which will call f1 and f0, and 0 and 1 will be returned, which will be 1 by adding them, and at last, as f3 and f2 have been completed, f4 will be 3, and thus this whole recursive function works. Okay, so what is the problem with this? Is there actually a problem with this? Actually, being honest, there is. Now what is the problem? So the problem is, let's quickly figure out a bigger problem. That is, we want to determine f7, and I am building this tree quickly. Hopefully all of you will be able to follow. This is not that hard to build. I am not going sequentially, just completing the tree for now. And so on. Actually, this will take a little time, and you know there are stuff. I am just partially completing it for now. As you see. So now you see that to f8 to be completed, f7 and f6 is to be completed, and all of these has to run at some point. The problem is, you are determining f6 once for f7 and again for f8, and this whole portion exactly like this will be here. And this will execute once and then again here. So isn't that kind of unnecessary? Because you have already computed f6 and then you are doing this again. It's like, let's say you and I are a complete stranger, and now the first time we meet, I ask your name. You tell me that your name is, let's say, Darth Vader, and later on we become friends. Then every time we meet, will I ask your name every time? No, because I remember it. You told me once that your name is Darth Vader, so I should remember it. So exactly the same case is happening here. f6 is a value that you have computed once, and then from further on you can actually ask for its value anytime, and you don't have to compute the whole process again because you already know the value. But according to this code that we wrote here, we calculate f6 or f5 or any of the terms multiple times. You can see in this term that we are calculating f4 here once again here, and once again there, 3 times. And as this tree grows larger, if you want to determine f20, then there will be many terms that will be calculated over and over again. But that is kind of unnecessary, right? We should try to avoid that. Before going any further on how to avoid that, this thing has a name, kind of, which is called overlapping subproblems. Many of you might understand it from this term, overlapping subproblems. It means that there are some subproblems which overlaps. So what is subproblem? A subproblem is a smaller version of a problem. So you are trying to find the 8th term of the Fibonacci series, for which you need the 7th and the 6th term. So f8 is a problem for which you need to solve 2 smaller subproblems, which is f7 and f6. And again for the f7 subproblem, you need to solve 2 smaller subproblems maybe, which is f6 and f5. So these are the subproblems. Subproblems are smaller versions of a problem. And why is it overlapping? Because in order to determine f8, you have to calculate some of these terms multiple times. and that's where it gets overlapped. So that's why this is called overlapping subproblem.